In trigonometry, sometimes you have a triangle that has missing information, either missing angles or sides, and you need to solve for them. A really good tool for this that we can use is the law of sines. So we're going to draw a triangle up here for now. Okay, so in our triangle, we have our three angles, our three sides, side A, B, and C. And then we have our angles. Opposite of side A, we have our angle alpha. Opposite side B, we have our angle beta. And opposite side C, we have our angle gamma. Right? And so what the law of sines tells us is that we can take the sine of the angle alpha over side A, and we can set that equal to, or it will equal, the sine of angle beta over side B, and both of those are equal to the sine of angle gamma over side C. Right? And notice in each fraction we have the angle and the side paired up that are opposite each other, right? So alpha and A, beta and B, gamma and C. So that is the law of sines. So we can take, so each of these three fractions will always be equal. And we can use those to set up equivalence equations to solve for information that might be missing in the triangle that we're trying to solve for. Right? So let's say we were presented with a problem where it tells us that angle beta is 34 degrees, angle gamma is 64 degrees, and side A is equal to 5.3. Okay, so let's go ahead and write that into our triangle. So we have side A is 5.3, angle beta is 3.4, and angle gamma is, I'm sorry, it's not 3.4, 34 degrees. 34 degrees, and angle gamma is 64 degrees. So I'm going to go ahead and I'm going to rewrite the information that's missing in black so it's different. So we have side C, side B, and angle alpha. They're both missing, they're unknown. So we're going to use the law of sines to help solve for these. So we're going to take this information from our triangle that we know already, we're going to put it into these law of sines equations. Right? And so we're going to end up with the sine of alpha, we don't know what alpha is yet, so it stays there, over A is 5.3, and that is equal to the sine of angle beta. Beta is 34 degrees, so we can write that in there, over B. We don't know what B is yet, so that's still a variable. So there's B. And that is equal to the sine of angle gamma, which is 64 degrees, over side C. We don't know what side C is yet. So, so with the law of sines, what you would do then is now you would take two fractions and set them equal to each other, and then you could begin to solve for your variables. But if you notice that no matter which two we put together, we're always going to have two variables that we don't know. So it'd be impossible to solve for any of these variables. So what needs to happen is we need to find some more information before we start using this. So the easiest one would be is to solve for the last angle. Because when you add up all three angles in a triangle, it's going to equal 180 degrees, right? So if we add up these two angles right here, that's going to equal 98 degrees, right? So alpha plus 98 degrees is going to equal 180 degrees. So we just subtract 98 from both sides, and we're left with alpha is equal to 82 degrees. Right, so now we just filled in more information so we can get rid of, so we can fill this one in, that's 82 degrees. And then we can come over here and put it into our law of sines equation. So sine of alpha is now sine of 82 degrees. Now we can start solving for some of the missing information, right? So I'm going to take this fraction right here and this fraction right here, and notice they're equal to each other, so we can use that to solve for b. So we have the sine of 82 degrees over 5.3 is equal to the sine of 34 degrees over b, right? So notice the variable we're trying to solve for is in the denominator, right? So it's much easier if it's in the numerator. So what's going to happen, what I'm going to do is we're going to flip the fractions over so that b is on top. Notice that if we have the equivalence equation, 1 over 2 is equal to 2 over 4. Notice that if we flip these, so we have 2 over 1 is equal to 4 over 2, it doesn't change the equivalence equation. They're still equal to each other, right? So we can do that with our equations here, and they're still going to be equal to each other. So what we have is, I'm going to grab this guy right here. So now we have 5.3 over the sine of 82 degrees is equal to b over the sine of 34 degrees. Okay, so we can plug this into our calculator, and when you plug in your calculator, make sure that your calculator is in degrees, not radians. We're going to get 5.35 is equal to b over the sine of 34 degrees. You can multiply each side by the sine of 34 degrees. Right, those are going to cancel out, and you're left with b is equal to 2.99, because we're just going to call 3. So now we can go ahead and we just found another piece. We can fill that into our triangle. And now we just leave side C. So we can go back over here, plug this one into our law of sines equation, right? And now we just need to set a fraction equal to this fraction, and then we'll be able to solve for side C. Notice I already know what the value of this one is. Over here, I already got started there. So I'm going to take these two fractions and set them equal to each other, right? So we're going to, again, we're going to flip the fractions because C is on the denominator. It's much easier if it's on the numerator. So we have 5.3 over the sine of 82 degrees is equal to C over the sine of 64 degrees, right? We know that this fraction is equal to 5.35 because we did it over here, right? And that's equal to C over the sine of 64 degrees. Again, multiply each side by the sine of 64 degrees. Those are going to cancel. And we're left with the sine of 64 degrees times 5.35 is equal to C, and C turns out to be equal to 4.8. So there we just solved for the last piece, last missing information for our triangle, and using the law of sines, we have solved for the complete triangle.